This is a photograph by this German artist named Michael Najjar, and it's real. I mean, he took this photograph. He went to Argentina to take it, but it's also fake. He's done a lot of work on it. He's actually reworked in Photoshop. He's reworked all of the contours of the mountains to have them shape the Dow Jones Index. So this picture was made in late 2009. That high apex and deep valley, that's the financial crisis, was taken when we were right there. I'm not sure where we are now. It's not just Wall Street, of course. This is China, the Hang Seng Index, which has, of course, very similar topography. I wonder why. And all of this is to say, this is metaphor. This is art, but that it's a metaphor with teeth, and that it's with those teeth that I want to speak through today to say a few things about math and how it affects our lives. How math, and really a specific aspect of math, which is algorithms, how they're sort of shaping the world around us. How math used to be something that we thought of as something that was sort of like derived from the world, and that now it starts to be something that actually shapes it. And these algorithms, which is, you know, if you're not a nerd, let's just say that algorithms are it's the kind of math that computers use to make decisions. They're not truth, but they get repeated over and over again, and they kind of calcify and they ossify and they become real over time. And I got to thinking about this a couple years ago, really for the first time on an airplane. I was talking to the guy next to me on the airplane, because I'm that guy. And he was a Hungarian physicist about my age. And I asked him, so what did physicists do during the Cold War in Hungary? And he said, well, mostly we were working on stealth. We were working on breaking stealth. And I said, well, that's an interesting job. How does that work? And he said, well, it's complicated. And he said, you'd have to understand how stealth worked. And I do, kind of. And so I'm going to explain it to you. It's a little bit more complicated than this. But basically, you can't just take a 52-ton airplane and just have a radar signal just pass through it like it's invisible. It's just not going to happen. If you send out a radar signal, it's going to come back. But if you can take that big thing, those 52 tons, and if you can make it somehow look like it's a lot of little things, right? Like, say, a flock of birds. It means that your radar that's looking for that is going to have to be able to detect every bird in the sky. And if that's what your radar is doing, it's going to be garbage, right? If you're looking for every bird in the sky, that's all you'll ever see. So the essential condition of stealth is to make the big thing look like this million other things. And he said, yeah, that's basically it. And he goes, the problem with that is that that's only true if you are a radar. And I said, well, what else have you got? And he said, well, we were looking for electrical signals, and we made a little black box that was looking for electrical signals moving through the sky that didn't have a radar signature. And when we saw one of those, when we saw an electrical signal moving through the sky at a certain rate, we thought, that's probably something to do with the Americans. So I said, that's impressive, a little black box that does that, and you've now negated 60 years of aeronautic research in the United States, so, like, you know, what's your act two? Like, where do you go from there? And he said, financial services. And I said, oh, financial services, because those have, you know, been in the news lately. And, you know, there's 2,000 physicists on Wall Street now. And I said, so what's the black box of Wall Street? And he said, well, actually, it's called black box trading. It has other names maybe you're more familiar with. Algo trading is one of them. And see, the reason that this exists is that big traders have the same problems that the United States Air Force has. So if you're like a big institutional trader and you're going to move like 1 million shares of Accenture through the sky, right, through the market, If you just come out and you just say, we're going to move these million shares, it changes the actual conditions of the market. So they engage in a kind of financial camouflage, right? They find a way to actually sort of, they use algorithms to basically break up those million shares into, say 100,000 shares of 1,000 or so, whatever, 10. So they engage in this kind of financial camouflage where they break up the big shares into all these little shares, and all of that's great because it kind of works, except that as surely as you can use math to break up the big thing into little things, you can also use math to find all those little things that are flying through the sky. Right? And that's exactly what happens, right? So basically, if you need to understand what 70% of the market is doing right now, 70% of the operating system formerly known as your pension or your mortgage, you can envision this as algorithms in conflict, right? As one algorithm that's setting out to hide itself from everything, and another set of algorithms that's setting out to find those. Except it's not one algorithm. There are thousands. There's maybe millions of them. And what could possibly go wrong with that, right? We found out at what was sometimes called the flash crash of 245 in May of 2010, when the when the United States stock market lost 9% of its value in 5 minutes. And the thing is that nobody knew why, because it wasn't anything that anyone was doing. And to this day, there's not a strong consensus as to what even happened, because it wasn't anything that anyone told anything to do. Because all a trader has at this point in their technology, or at the front end of their technology, is just a monitor that shows the numbers moving up and down, and a black button that says, stop. And the thing is that this is where we're at now, is that we're effectively writing the unreadable, right? We're all of us kind of collaborating on this like vast collaborative work that we can't read anymore. It's invisible, it's illegible. There's a couple people, there's these math nerds up in Boston, they're called nanics, and they can actually, they'll reach into the market. They'll gather more data, arguably, than the SEC in the United States. And they gather all the data from the market because what they're trying to do is read this thing that we are writing. And they'll go in and they'll crunch all the data, and every once in a while they can find one of these algorithms wild in there, and they grab it and they pull it out and they pin it to the wall like a butterfly, right? And they do what we've always done, right? They do what we've always done every time we ever looked up at the sky and saw all the stars and thought, how do you navigate by that? They give them shapes and stories, and it doesn't matter that the stories aren't true. They allow us to understand where we are. And so they move through the market and they find these. And so they found one, this one they called the knife, the carnival, the Boston shuffler, Twilight. And the gag is that the knife and the Boston shuffler, of course, they're not just running through the stock market. They're in your lives, my life, much, much deeper than that. And you can see it, for example, if you go to buy a book on Amazon. This is a book about the genetics of flies. I don't know how many of you have read it. It's out of print, which explains why it's kind of expensive. It was going for $1.7 million at one point, and you would have been wise to snap it up at that time, because about 3 hours later, it was $23 million, $23.6 million for this out-of-print volume about flies. And it's an interesting book. It's maybe not that interesting. And what you see in this, in Amazon, is the same thing that you see in Wall Street, which is evidence of algorithms that are moving through the world without any human supervision at all. Okay? So this is a price that was determined by two algorithms used by two different booksellers on Amazon that were actually in conflict, that were caught in a loop, that allowed this price, that produced a price of $23 million. And the only difference between the prices on Amazon and the prices on the market is that this still requires a human to say, yeah, sure I'll pay $23 million for that. But in the market, that's not true, right? In the market, when shares go to $99,999, when they reach the actual local maximum within the market, they will still transact if there's another algorithm, like the same awesome algorithms that produced a 23 million value for this book, will think, yeah, it's probably going to be worth more tomorrow. And as with Amazon, so with Netflix, right? So Netflix is the primary means of video distribution in the United States at this point. It uses an algorithm ultimately called pragmatic chaos is the name of the algorithm that they're using. Just to give you numbers, how do people decide what they're going to watch next on Netflix? 60% of every decision that's made about what people watch, of the 20 million people who use this to watch stuff, 60% of that comes from the recommendations that that algorithm makes. Just that. Okay? So one algorithm that nobody knows exactly what's in there determines what 60% of us are watching. But what if you could take that like a little bit further, actually, and say, well, what if instead of doing it afterwards, what if you could determine whether people are going to like the movie before the movie gets made? So that's a British company that's out in Hollywood called Epigogics. And they have story algorithms, and they will run your script through that using some dark math that they've developed, and they can tell you before you've cast it, before you've shot it, before you've found a director, they can tell you whether that's going to be a $50 million or a $250 million movie. And the thing is that this is no longer information, right? This isn't finance. This is actually culture that's being shaped here algorithmically. These are the same things that are moving through the market, but they're actually beginning to shape culture and determine a kind of physics of culture. And if these algorithms crashed, right? If the Epigogics algorithms crashed, if the Netflix algorithms crashed, how would we know? What would that crash actually look like? So let's get concrete. These are the ones that are in your home, right? These are the algorithms that are in your home. These are two algorithms. I don't know how many of you use cleaning robots here in France. They're becoming popular in the States. These are two different ones, the Roomba and the Nido. If you do a time exposure at night and actually track them, you can see these two robots that are just trying to clean your floor actually have very different ideas of what clean means. And in the same way that people are optimizing their writing for the Google search engines, what will you move around in your bedroom, and for which criteria? And maybe that will depend on the robot that's cleaning it. But they're not the only architects using algorithms. You see it here. This is a new type of elevator. It's called a destination control elevator. I don't know if you've come across these yet. Popular in Midtown Manhattan. They are, it's basically using what's called a bin packing algorithm, which solves this terrible problem that you've had all these years, which is where you get into an elevator and it's filled with all different people and they're all getting off on different floors. And wouldn't it be easier if you typed in what floor you were going to get into before you get into the elevator and have the elevator determine which elevator you should get into, which car you should get into, and to sort of sort you into the correct car so that it only has to make one stop. And the only problem with this is that when you put people into this car, you see what's missing, right, inside the elevator, right? You know, buttons, right? Like anything that has anything to do with human agency. And what they find is that when you put people in this, that people kind of freak out, right? Because what we've done is we've designed these not around the human use, but rather around a kind of machine dialect. It barely speaks any human, right? So yes, even architects are using algorithms as the fundamental criteria for what happens there. And to take that to its furthest extreme, and to kind of wrap this up, to take that to its furthest extreme, we have to turn back to Wall Street, over here, to understand what's really going on. These are a bunch of different algorithms that have been named: Cherokee Nation, Bluegrass, Marco Polo, Bandsaw, Frog Pond, and Tilt. They're down there on Wall Street. And the thing is, the problem with this is that these things are they're about 20 blocks away from what's called a carrier hotel. And a carrier hotel is where the internet comes up into Manhattan. There's one here in Paris, there's probably two here in Paris, there's one in any major city in the world. And it's actually where the internet comes up. And the problem is that for these algorithms, Cherokee Nation, Bluegrass Bandsaw, they have to get their signal all the way up to that carrier hotel. And, you know, that's got to travel through fiber optic cable, and it will take 500,000 microseconds to get there. Okay, so 500,000 microseconds, which is, by the way, you can't click a mouse that fast, right? It's impossible. This is off the scale of human perception, right? But if you're 5 milliseconds behind on Wall Street, you're a loser, right? You have no hope in this, which is why most of Wall Street, such as it is, has relocated all of their activity up to around that building. for you fans of 60 Broad Street, up around this building, to actually relocate the algorithms up there. And then you realize that Manhattan itself, and it's not just Manhattan, it's London, it's Paris, it's any financial center in the world, is actually beginning to restructure itself, is actually beginning to optimize itself to perform less like a city, more like a microchip, where the speed of the transactions are actually determining the value of the real estate, right? Because you've got to get as close as you can to any of that. And if you want to like zoom out even further, if you still don't think that this is that extreme, you can zoom out a little bit further, and if you come up over the United States, you'll see that there's a pipe being dug, there's a trench being dug between New York City and Chicago. It's already done, actually, to allow the transmission of a signal for 13.3 millisecond round trip, just so that the Knife and the Carnival and the Boston Shuffler can close the deal 3 milliseconds faster. And when you realize that we're using rock saws and dynamite, right? We're using rock saws and dynamite to blast through the United States. We're doing the same thing to the ocean floor right now between London and New York. All so that an algorithm can close the deal in Chicago 3 milliseconds faster. And that's all for a communications framework that no human will ever touch. You realize that this is the next frontier of manifest destiny. So where can you go? What is the ultimate manifest destiny? It hasn't been built yet. It's a theoretical, maybe it's even parody. I don't know, because I can't even understand it myself. It comes from a bunch of MIT mathematicians, and it has something to do with light cones and quantum entanglement, stuff that I don't understand and can't explain, but I know what it means, which is that these red circles, that's where the humans are, that's where the markets are, and that if you really want to optimize, if you really want to make sure that your algorithm is going to perform at its highest function, you're going to have to locate it at one of these blue dots. And the thing that you'll notice, even just casually, if you look at this, is that a lot of those are actually in the middle of the ocean. And that's cool, because we'll solve that. We'll build like bubbles under the ocean or platforms or something, because we can do that. We'll like part money, we'll part water to pull money out of the air, because it's a super bright future if you're an algorithm. And the thing is it's not the money. It's not the money itself that's amazing, right? It's the fact that we're willing to do this. It's the fact that we're willing to terraform the Earth, you know, with this kind of algorithmic efficiency. And when you think about that, and you go back and you look at the photographs from Michael Najjar, you realize that these aren't metaphor, they're prophecy, right? For the tectonic effects of the math that we've made in the world. Because the landscape, it's always been shaped by two different things. It's always been shaped by nature and by man. And now, it's being shaped by a kind of third co-evolutionary force, the algorithm. And we'll understand those as nature, because in a way, they are. Thank you.